Hi, I'm Tomoya Shimura from Disaster Prevention Research Institute, Kyoto University, Japan. Would like to talk about climate change impacts on future wave climate. This figure shows our results of future changing wave climate due to global warming. It is expected that climate change can alter the long-term characteristics of global wave climate, such as wave height, wave period, and direction, as shown here. Wave heights around Japan are expected to be decreased by about 10%. Today I want to focus the spectral characteristics of wave climate around Japan. Before I will talk about the future wave climate, I want to talk about the historical wave climate around Japan. We have already conducted that long-term wave climate hindcast based on atmospheric reanalysis data spanned from 1979 to present. The wave calculation was conducted by WaveWatch 3 and nested from global to Japanese coastal area, as shown here. We found that this data has good accuracy compared with V observation. Based on this data, we represent the 34 years wave climate around Japan by 34-year average two-dimensional wave spectra, as shown here. So this figure is very difficult to see, but this figure shows the spectral characteristics of around Japan. The characteristics of the spectral wave climate are investigated by classifying them into three types. In Japan Sea area, here these locations, the mean wave spectra can be characterized by narrow bandwidth, and if you look at the Pacific side of East Japan, these locations, the mean wave spectra are characterized by spectral peak in the northeast direction, which correspond to swells coming from this direction, and wave spectra in the Pacific side of West Japan can be characterized by bimodal peaks and a long period component, which is generated by tropical cyclone. So we found this representation of wave climate by mean wave spectra is very useful. Therefore, we applied this representation to the future changing wave climate around Japan. This is the configuration of wave climate simulation based on global climate model. This configuration is exactly same as that of historical wave climate hindcast I showed the previous slide, except for the forcing of wind and sea ice. This wave climate simulation has been forced by global climate model, so-called MRI-AGCM. The computational period are 25 years during 1979 to 2003 for historical wave climate, and 2075 to 2099 for RCP 2.6 future scenario, and also 2075 to 2099 for RCP 8 scenario. RCP 8 scenario is the worst scenario of global greenhouse gas concentration scenario. The validation of wave climate simulation was conducted. We conducted the comparison of wave climate simulation with the Japanese V network, so-called NAOFAS. We found that the wave climate simulation has good accuracy. So this is the validation result for significant wave height. The bias is about plus minus 0.2 meter, so which means good agreement with the observation. And if you look at the quantile plot, there is a good agreement between the observation and the wave climate simulation from small wave height to high wave height, like this, for all the location along the Japanese coastal area. So from now on, I want to show the result of future change in the wave climate around Japan. This is the projected future change in the mean significant wave height and RCP 8.5 scenario and RCP 2 scenario. So you can see the decreases in wave height in the entire domain, and the RCP 8 future scenario, the magnitude is about 10% here, and this is the wave height. But you look at the mean wave period, you can see the also decrease in the mean wave period by about 3%. So this result is consistent with previous global wave climate studies. So in the RCP 2 scenario, the future change is about up to 5% here. The magnitude is much less than the RCP 8.5 scenarios. So on the other hand, if you look at the north of Japan, here you can see the increases in wave height. This is due to sea ice loss here. Next, we analyze the wave climate changes in the point of view of wave spectrum, same as wave hindcast as shown before. The wave climate is represented by mean two-dimensional wave spectra, as shown here. So the long-term average wave height period and the direction are also defined by the mean wave spectra. These equations of definition are same as ordinal significant wave height, mean wave period, and mean wave direction, but based on mean wave spectra, as indicated by these red squares. As a result, these averaged variables corresponds to averaged value weighted by squared significant wave height. By this definition, averaged value of wave height, mean period, mean direction are related with each other via mean wave spectra. These are the projected future change in mean wave spectra for represented three locations of Japan Sea area, Pacific side of West Japan, and Pacific side of East Japan. The contour is mean wave spectra in historical climate, and the shade is projected future changes. Wave direction is defined by direction waves coming from. Blue line here is mean wave direction of historical climate, and red is future climate. The future changes shows decreases in energy along entire frequency direction domain, and shows larger decreases at the clockwise direction of mean wave direction here. This larger decrease result in the anti-clockwise changes in mean wave direction. And this decrease in energy entire frequency direction domain result in the decrease in the significant wave height and the mean wave period about 5% to 10%. If you look at the Pacific side of West Japan, you can also see the decreases in energy along the entire frequency detection domain, which leads to the decrease in the wave height and the wave period. But there is a less deviation of decreases compared with this location. This leads to the no change in mean wave direction here. If you look at the Pacific side of East Japan, you can also see the decreases in energy along the entire frequency domain. Here also decrease in wave height and wave period about 5% to 10%. And you can see the larger decreases here at the peak direction. This leads to the clockwise changes of mean wave direction as shown here. So this is a summary of future change in spectral wave climate around Japan. So here is Japan. So this is very difficult to see. But here and here and here are the representative three locations I showed in the previous slide here. The wave height and the period would be decreased in the future around Japan because the energy would be decreased in the entire frequency detection domain, same as these figures. In the Japan seaside, the future changes is characterized by larger decreases in the energy coming from north, which results in the anti-clockwise changes in mean direction up to 3.5 degree. In Pacific side in East Japan, here, these locations, the future changes is also characterized by larger decreases in energy coming from north here, which result in clockwise changes in mean direction up to 4.5 degree. On the other hand, Pacific side of West Japan locations here show no change in mean wave direction because of less deviation of the decreases in energy in the spectral domain. So future change in wave height, period, and the direction can be discussed in this study consistently because of analysis on the this kind of mean wave spectra as shown here. That's it. Thank you.